Hi, in this video, we're going to look at more about IPv4 subnetting. This time, we're going to look at calculating how many subnets or hosts do we need. Okay, so in IPv4, once again, we have the 32 bits, which only gives us 4.29 billion addresses, and we have to borrow from the host portion to create our subnets. Okay, so as we move from IPv4 to IPv6, we have to increasingly go through this exercise of trying to conserve and best utilize our limited IPv4 address space. We only have so many addresses, and we have to figure out, well, if I have a barrel of 100 apples, how do I best utilize that? I might have one network that requires 50 apples, but I have another network that only requires 2 apples. How do I best divide my network? Or I have to divide it into 2 big networks and take one of the bigger networks and subdivide that further. And we're going to see that's actually called variable length subnet, VLSM, variable length subnet masking, that we'll talk about in the next video. But I bring it up here because it's just, going through this exercise, and I'm going to show you a bit of this exercise in this video. It's just another reason why we need to move to IPv6, because we shouldn't have to be worrying about conserving these bits and how we're allocating this address space. In IPv6, we have 340 undecillion addresses, and it makes address planning and our subnetting very, very, very easy, as you'll see in a later video. All right, so calculating the number of subnets and hosts. Okay, so first of all, if you have 1 bit, you only have 2 possibilities, 0 or a 1. That's it. If you have 2 bits, you have 4 possibilities, 0, 0, 0, 1, 1, 0, 1, 1. 3 bits gives you 8 possibilities, from 3 zeros to 3 ones. 4 bits gives you 16 possibilities, from 4 zeros to 4 ones. Notice that as we increase each bit, the number of bits from 1, 2, 3, 4, we double the number of possibilities. So 5 would give us 32, 6, 64, 7, 128, etc. So we can extend this table and keep on going and going and going, okay? Which, if you're taking a certification exam, we want to write this out so you can do these little calculations if necessary. Personally, I think we need to get beyond this and just move to IPv6. You've heard that from me plenty of times. But it becomes an exercise in almost frustration at times. But it's not hard. It's not hard. Let's see how we can use this chart. Let's say I have a network address with a /24. Okay, the network address is 192.168.1.0, and we have a /24 mask, 255, 255, 255.0. But we need to subnet this network into as many subnets as possible, but we need 60 hosts per subnet. Okay, so what will give us 60 possibilities? Okay, so 60 possibilities, what will give us that is borrowing 6 bits. 6 bits of something will give us 64 possibilities. Well, we need at least 60 hosts per subnet, or maximum, I should say, 60 hosts per subnet. 64 6 bits will give us that. So if we reserve 6 bits for our host, that will give us our 60, in this case, 62, because we lose 2 hosts per subnet. That will give us our 60 hosts per subnet required. Okay, so we're going to leave the last 6 bits for the host portion, but we can extend our mask from 255, 255, 255 from a /24, another, what do we got left over there? Looks like 2 bits. Yeah, so we extend our mask 2 bits. Okay, so we extend our mask from 255, 255, 255.0 to 255, 255, 255, 192 to a /126. Okay, we have our 6 host bits. Gives us 64 minus 2, 62 hosts per subnet. How many subnets do we have? that'll give us? Well, we extended our subnet mask 2 bits. So that'll give us 4 subnets, each subnet with 62 hosts. All right, so we can actually take a look at this another way here. So we have 6 host bits. 64 minus 2 gives us 62 usable hosts. 2 subnet bits. Okay, and so we can actually look at the subnets. Here they are. Okay, 0, 0, 0, 1, 1, 0, 1, 1. There's our 4 subnets. And remember that little trick we learned in the previous video? Okay, 64 total hosts per subnet, not subtracting the 2. Notice that each subnet increases by 64. All right, let's look at it another way. What if I have this same subnet address, network address, 192.168.1.0, 255, 255, 255.0, but this time my requirement is the subnets. I need 6 subnets and as many hosts per possible, host per subnet as possible. All right, let's look at it in binary. I need 6 subnets. What will give me 6 of something? How many bits do I need to borrow to give me at least 6? I need to borrow 3 bits. So this will be my subnet bits. I'm going to extend my subnet mask 3 bits. Okay. So let's see what that gives us. This gives me a new mask of 255, 255, 255, 224. Okay, so I'm extending it to a /27. Okay, number, so what does that leave left over for the hosts? Well, I have 5 host bits. 5 host bits gives me 32 minus 2, or 30 hosts per subnet, usable hosts. Okay, so we have 3 bits for the subnet, 8 subnet bits. I'm sorry, 3 subnet bits, 8 subnets, each one with 30 usable hosts. Okay, again, looking at the subnets, okay, I look at those 3 bits going from 3 zeros all the way to 3 ones. I get my 8 subnets. Again, remember that trick in the previous video, 32 total hosts. Okay, so notice that each subnet increments by 32. All right, hope this helps you understand and at least get you on your way to calculating the number of subnets hosts needed. You can use this for any subnet mask. Okay, we use something fairly simple, but you can use this for not just 3 bits, 5 bits, 6 bits, but 8 bits, 9 bits, 10 bits, 12 bits, whatever you need. Okay, hope this helps.